Hi guys. So in the second paper, uh, we had seen GRPO Group Relative Policy Optimization paper. Now we'll see look into this mathematical implementation, simple mathematical implementation. First, let's cover the theoretical part quickly with some real numbers. So what's PPO? It is the standard RL approach which is used. A simple 7 billion parameters model has two models, which is an actor and a critic. Both can take up to 70 GB of space, adding a total space of over 140 GB. Even the normal H100 is up to 80 GB, so we won't be able to fit those two models in one GPU. So why does this critic exist? So for every token generated, a critic predicts how much total reward it's to be given. So its job is to steer the model into the correct direction. But it means you'll need a second model as large as the first one. So what's GRPO? It replaces the critic with a group. So there's a prompt and there is an answer, and the GRPO samples 8 answers from the model. So like there are 8 answers. These three are correct. So it will be given a reward of 1, else 0. In the case of logical reasoning, the rewards can be in between the ranges from 0 to 1. So yeah, the total group average reward is 0.375. This is the baseline. So yeah, 0.625. So for the first one, which is correct, we move the model towards this direction, and for the ones which is incorrect, we move the model away from this. Okay, so over here you don't need a second model, just simple maths. So yeah, we use clipping to stop the model from overstepping its boundaries. So basically, including stability. So over here epsilon is zero point 0.2. So the clip range will be 0.8 to 1.2. So see, we have the old probability and the new probability and the ratio, and how much is used, and this will be the clipping range. It will be from 0.8 to 1.2, so that a model does not take any drastic change steps. So yeah, extra 70 GB overhead. So now let's look into the math implementation. So the simple group average is 8, group samples total is 8, epsilon is zero point 0.2, learning rate is 0.08, and 400 steps will be used for performing a training model. So for our actual GRPO, see, this is a prompt given in an actual LLM. The actor samples the full text completions. Okay, the answer is this, or the answer is this, and the reward scores after each completion. Correct answer will be given a high reward. Wrong answer will be given a low reward. Okay, so this is the policy probability of the sample tokens. This demo uses a tiny neural network, so we are using fixed multiple choice candidates instead of the free form text. Okay, so we will be giving choices for a model and steering towards the correct direction. So what stays the same? Like we sample a group of outputs, score them, we compute the advantage, increase positives for positive advantage outputs, decrease the probability for negative outputs, use PPO style clipping. Okay, so yeah, this is only for demonstration purpose. So what are the four main GRPO equations? This one, first one is a policy ratio. It is the ratio of the new policy probability to the old policy probability, meaning a same model. After its change, we calculate the weights. Okay, first one we remember them, and the second one also we calculate. So this will give us the policy ratio. Group advantage, so we individual rewards minus group mean rewards. Okay, so this is the second equation we need. Clip surrogate objective, the minimum ensures that we cannot exploit large values. Okay, so the range which you said 0.8 to 1.2. Then the last one is GRBO loss, meaning the mean over the entire group. We back propagate and update the values. Okay, so this is the loss. This is what gets updated while back propagation. So one step dissected. So let's take a problem 6 into 7. There are 5 choices. The correct one is 42. Okay. So this is simple maths, the logics and probability, and the candidate probability for each one of them. Uh, this probability is zero point 0.2, which is the correct one. Okay. So initially the model does not know anything. So this this is the step which is correct, right? And other steps are wrong. So we suppress those steps and we reinforce, means we stir the model towards this directions. Okay. So yeah. So the next step is sample 8 outputs and compute the advantage. This is done. Uh, so now we'll start the training on 400 sample. So give me a moment. Yeah. So it's trained. Yeah. So we are finished with our training. 400 steps. Epsilon is zero point 0.2. Learning rate is 0.08. So this is a reward bar. See how it's increasing for the correct samples. Okay. So this is the result. Like how much reward which is given, average reward which is given for the correct steps. So 0.85, and what is the final probability? So you're seeing like after our training, initially it was zero or very less, but slowly and steadily we stirred the model towards the correct answer, and this is the final bar. So see the first one which is correct, you're seeing the shift, and see the shift for this one. Before it was 0.1985 the probability. After after training it has become 0.9876. Similarly for zero point 0.2 to 0.9808. So yeah, when the policy is random, we calculate the mean, which is very less. Then after correct answers we get an advantage of zero point 0.8. Okay. So as the policy improves, the mean improves. Okay. So when the mean becomes 1, the advantage becomes 0, and thus the gradient signal disappears. So the model does not perform any self improvements after that. Like no learning rate is needed. So what's the full algorithm? We sample the group, we score for each output, and those three equations which I explained above: the group baseline, the per sample advantage, then the policy ratio, then clipping the sample, then calculating the loss, then calculating the gradient step, and updating all the weights and repeating it. Okay, so no critic is needed, no value network, no token level baseline. The group is the baseline. So yeah, I hope you like this video, and in the next one I'll be looking on MLA. Thank you.